Okay, hello everybody again. Um, as I promised, I will do the rows reduction. We're gonna do two exams today because two reasons. Number one, my professor didn't teach it when we take it, so you guys honestly, that's how it be sometimes. It sucks. And then you know the feeling where you scramble all the books and you find okay, what's the direction, what's the formula for doing row reduce echelon, and you think your life sucks. And the second reason is today is kind of rainy. I don't feel like going out, so okay, let's get started. We start with the let me give you one example. Why do we do row reduce echelon, right? Because algebra is not enough. We need linear algebra, guys. Linear algebra is way better. It's hard at first, I promise. It's kind of tricky, but once you love it, you can see that we're so small compared to space and time. We're just like tiny creatures. Okay, so I'm gonna write down the matrix. So our goal is we try to solve this system of equation, right? 3x1 plus 1x2 minus 5x3 plus no, sorry, minus x4 equals 0. Then we have 2x1 plus 1x2 minus 3x3 minus 2x4 equals 0. And then we have x1 plus x2 minus x3 minus 3x4 equal 0. Okay, so how are we gonna do this? Now, number one, you had to set up the matrix first, right? So you're gonna set up like this. So look at the coefficient. Okay, so each row, so okay, this is row 1, row 2, and row 3. Okay, so it would be 3, 1, negative 5, negative 1. Okay, and then the second row similarly, and then you have to write like this. All this equals 0. Okay, the second row is 2, 1, negative 3, negative 2, 0. The third row is 1, 1, negative 1, negative 3, 0. Okay, this is I forgot the term for this. I really do forget the term for this, but I believe there's a way you can call it. But and then since this is on 0, look, very important here. Okay, since this is on 0, you can rewrite like this. You can rewrite this as 3, 2, 1, 1, 1, 1, negative 5, negative 3, negative 1, negative 1, negative 2, 3. Okay, because no matter what operation you do, a simple way to explain to this is no matter what operation you do, 0 times something minus 0 times something, or whatever you do, it's still 0, so it doesn't matter anymore. Okay, we're gonna write like this. Now we're gonna get into the algorithm. So I Google like Gaussian elimination algorithm. Okay, and I found two links. I found the first link, you guys would know, is on page 37 of page 455. The second link is page 39 out of 455. It's from a textbook. I accidentally came up with it, and I'm gonna follow this algorithm. Okay, I'm gonna follow the 39 one, and let me talk a little bit about all that algorithm, and then I do it. Okay, so the algorithm says like this: you go from left to right. That's the first, left to right. Okay, this is, we're not In this case, we're not gonna think like an Arab speaker or Hebrew speaker when everything is being done from right to left. Now in this operation, we have to do it from left to right. Okay, that's the first thing. The second thing is it's gonna be like this. Okay, and imagine you have something like this. Let me describe it. You're gonna make sure there's a 1 here first. Okay, and then you go down. You eliminate. You make this 0. You make this 0. Okay. Then you're gonna make sure there's a 1 here, and then you go down. You make this 0. Okay, and then you keep doing that. Okay. And then after all, you come back, you come up. Okay, if you want to clean it, you make sure everything here is 0. Okay. And then you ask me, Justin, this is not always like this. This is so ideal, right? How this definitely you cannot create like a diagonal matrix. Let me throw some term for you. Like, let me remember. I write out some term. Just make sure you what is that. Okay, so diagonal matrix, upper triangular matrix and lower triangular matrix. Yeah. Okay, cool. Now go back to our example. Where it is. Okay, so what happened if you when do you stop? Right? When do you stop? What happened if it's not ideal like this? Okay, you stop when basically there's something called leading coefficient, right? Be careful. The word leading does not mean what you think it is. Leading is not, in this case, does not mean sexual. Does not have a sexual context. It means the first one. Let me explain to you. It means that each row will have a leading one. Okay, each row will have a leading one. Like, let's say leading one is here. Okay, so to qualify to be a leading one, you have to have 2 criteria. The first criteria is everything below it. Everything to the left of it have to be 0. Okay, everything to the left of it has to be 0. Okay, and the second criteria, I believe, is everything in its column have to also be 0. I could be wrong on this. I will revise this video later. Okay, but either both criteria or one criteria. Maybe the column one. I'm pretty sure. Like, you have to be the only one in that column, and then the rest is 0. So, okay, that's when you can stop. That's one of the stop place. The other place when you can stop is you have like a bunch of 0. They call it zeros row. Okay, that's the second place you can stop. Okay, too much talking, no doing. Now we're gonna start the example and we're gonna do this one and you see what does I mean by that. Okay, so I'm gonna rewrite a matrix, which is, what is this? 3, 1, -5, 3, 1, -5, -1, 2, 1, -3, -2, 1, 1, -1, -3. Okay, I'm gonna say this is R1, R2, R3. Okay, how do you do row reduce? Okay, the way you do it is, okay, the first one, remember, create the 1 on the top left, right? So how do I generate it? Generate the 1 on my top left. I'm gonna replace R1 with R1 minus R2. What does it? And then the rest I keep the same. Okay, so what does it mean? It means that after that it will it means, okay, now R1, instead of being 3, it will become 3 minus 2, which is, this is 1 minus 1, which is 0, -5 minus -3 is -2, -1 minus -2 is 1. Okay, 2, 1, negative 3, and then you rewrite everything. Remember guys, in Mathematica, if you don't know what to do with the term, just rewrite it, just keep rewriting it, okay? Okay, then we have generate the first one in top left, okay? This one right here, this one dude right here. Now you clean everything below it in terms of row, okay? Clean every row below it, make sure it is 0, and we're talking about the first column, okay? First column. All right, so how to make this 2 become 0? Simple. I'm gonna replace R2 with 2R3 minus R2. Okay. So what does it look like? It looks like okay, R1 in chain. I'm gonna rewrite it. R2, I'm gonna relate 2 times 1, 2 minus 2 is 0, 2 times 1 is 2, 2 minus 1 is 1, 2 times negative 1 is negative 2 minus 3 is 1, and then 2 times negative 3 is negative 6 plus 2 is negative 4, exactly. R1, I didn't do anything, I keep rewriting it. Okay, and similarly I can clean up R3 like any one of y'all, if you can see it, and I'm sure some of y'all is jumping in the chair in your chair right now, say, oh, R3 you replace with R3 minus R1, right? Because 1 minus 1 is 0. I saw it, I knew it, right? Okay, I'm gonna rewrite everything because didn't do anything, you know. We didn't do anything, so we just keep rewriting it. So R3 minus R1, so 1 minus 1 is 0, 1 minus 0 is 1, negative 1 plus negative 1 minus minus 2 is 1, and negative 3 minus 1 is negative 4. Okay, awesome. Now we're done with the first column. Okay, so the first column is 1 0 0, and now the second column is we have to do 2 things. We move on to the now we move on to the second column, and we have to make sure that this guy's 1 and everything below him is 0. Okay, so is that guy only 1, that's good, but this one right here have to be 0. Okay, so how are you gonna do that? You're gonna replace R3 again with exactly, you're gonna replace R3 with R2 minus R3, right? Okay, R1 R2 is the same, we keep rewriting it. 0 1 1 negative 4. So okay, 0 minus 0 is 0, 1 minus 1 is 0, 1 minus 1 is 0, negative 4 plus 4 is 0. Okay, cool. Now you see something weird. So if you see something like this, right, I think you can stop, because the next goal on this, you remember what's the next goal, why this is a good place to stop. The next goal on this guy, you have to make it 1, right? You can't. Impossible. No way. So yeah, if you see something like that, you can stop. You can pretty much stop. I mean, the next step, you can clean up, you know, you have to come back, you know, you make sure, you know, on this thing above this is clean, on this is clean, but yeah, it's 0 here, it's clean up. So I think this is a good place to stop. So ladies and gentlemen, this is our row reduced form of the matrix. Now, some of you might question, I don't trust this dude, I don't trust this Justin dude who think that he only read one example and he think he know the whole algorithm, right? How do you check it? Okay, let me introduce you guys to a program. It's called Mathematica. Okay, Mathematica. Okay, and this is I'll give you the code to check the row reduced form of a matrix. So let's say, what is our matrix again? Anyone in the comments? Oh, I'm sorry, I'm living. I'm not live, so I always have that. Okay, so is this 1, 3, 1, -5, -1, 2, 1, -3, -2, 1, 1, -1, -3, right? This is our matrix. You want to see the row reduced form of this? Okay, so this is the command you're gonna put in. You say row reduce. This is in Mathematica, okay? Okay, then you bracket this, and then you write like each row of the matrix, okay? So you write 3, 1, -1, -5, -1, comma 2, 1, -3, -2. In Mathematica, comma, she understands it as she understands comma as you move down to a different row. Okay, so this is 1, 1, -1, -3. Close it again, then bracket. Then make sure you write in a matrix form. Percentage. Okay, this is the code you can use to verify any answer, like in the future, like if your professor assign you a problem, okay, and you want to assign this is row reduced form or not, you can use this code in Mathematica. Percentage mean that the above input, okay, this is what percentage mean. Okay, that's the first part. Thank you everyone for watching. I will make the second part where I talk about one of the example in my exam and why you need it. Thank you so much for watching my video, and I hope you have a good day or night on wherever timeline you're on. Thank you so much.